Alright, number 39. Read through the problem, blah, blah, blah. The words I'm looking for are maximize or minimize, and I don't see it till the very last sentence. It says maximize profit. So, I need some sort of function in terms of profit. So go back through here and pick out some information. They cost $250 and $400. But that's not that it doesn't have to do with the profit. That's the cost it is to produce them. The profit, the $250 model yields $45, and the $400 model yields $50. So my profit's going to be those two added together. So if that is the objective equation, then whatever's left here has to be some sort of constraint. Let's read the words more. The merchant estimates that the total monthly demand will not exceed 250 units. So of all the ones we sell of that model and all the ones we sell of that model, they will not exceed 250 units. So they have to be 250 or less. The merchant does not want to invest more than $70,000. So the first model, the $250 model, and the cost that it takes to produce the $400 model cannot exceed $70,000. And I think we've pulled out all the information. So there's only two constraints, one objective equation. We need to get these in a form that we can do on the calculator. So y will be less than or equal to 250 minus x, and 400y will be less than or equal to 70,000 minus 250x, or y will be less than or equal to all this divided by 400. So that needs to go in the calculator, and that needs to go in the calculator. And to save us some button pushing in time, look at that. They're already in the calculator. Okay. So I plotted them both. I had to do some window adjusting. That's the window I used. I took -20 just enough so I could see the x-axis, and same thing with y. And then I picked just a bit above the 250 for my x and my y. So there's my graph. Now to find the feasible region, we have to look at the inequalities again. Y has to be less than or equal to 250 minus x. So it has to be below this line. So that cuts it into just this. And we didn't say anything about it, but we have to have greater than 0 or greater x and y, because you can't make a negative amount of product. It has to be less than this one, which ended up being I think 175 minus 5/8x. So it's got to be below here. So the feasible region is bounded by that point, that point, that point, and that point. It's 0, 0 is not going to maximize the profit. So this one is, forgot the number again. This one is 175. So I have a point of 0, 175, and I have a point of whatever this is. So let's find this intersection. Second trace intersect. I want the intersection between that line and that line. 250. And looks like I have one more point down here. Now I could go back and plug 0 in for y and find out what the x-intercept is, or I could find the 0 on the calculator. Let me make sure what line we're on here. On the wrong line. There we go. So I got to pick a point above the 0, hit enter, go over here until I get below the 0, hit enter, and my 0 is at 250. So these need to be plugged into the objective equation, so I got to get out of my graph. For 0, 175, that would be 0 plus 50 times 175. That would be 87.50 profit. This one would be 45 times 200 plus 50 times 50, or 11,500. And this one would be 250 times 45 plus 0. 250 times 45 is 11,250. So to maximize the profit, he needs to make 200 of the first product and 50 of the second product.